Yeah, good morning. To start this event today, I hope we have a good mood and run smoothly for this event. I will introduce our speaker today. First, we have Mr. VB Ardi Sufianto as a graphic design lecturer from Stekom University. And then we have Mr. Serhi Choprov as a doctor of technical science professor from Zaporizhzhia National University. And I will introduce myself also. My name Novita will be moderator for this event today. Before we start for this event today, I would love to tell you, we want us to pray first according to your own religion and belief. So everyone, let's pray start together. Pray finish. I hope this event will be enjoyable and worthy of knowledge. Before we start opening for presentation, we will hear opening speech by Mr. Wibi. Yeah, for Mr. Wibi, the time is yours. Thank you.
Okay, thank you. Okay, thank you, Miss Novita. Hello, everyone. Thank you for the time. Good morning, ladies and gentlemen, and the Honorable Dr. Joseph Teguh Santoso as a rector of Stekom University, Mr. Serhi Choprov as a doctor of technical of science professor from Zaporizhzhia National University, Miss Alina Assaul of Head of International Relations from Zaporizhzhia National University, and Miss Anggi Novita as a moderator for today, and also all of our distinguished guests. Good morning, ladies and gentlemen. Thank you to each and every one of you being here today at this wonderful place. My name is VP Ardi Alfianto as a graphic design lecturer from Stekom University. It is such an honor for me to speak on behalf of the organizer. Let me begin by giving you a warm welcome to this event visiting lecture today. May I first take this occasion to pay tribute to all of the audience of this visiting lecture from Zaporizhzhia National University, Ukraine, to University of Science and Computer Technology, Stekom University. It is a great pleasure and an honor for me to deliver this opening speech of visiting lecture. May I first take this opportunity to express my gratitude and appreciation, as well as extend an cordial welcome to all of the audience in today's event. Good afternoon to each one of you who designed today. It is a moment of extreme pleasure to welcome the guests who are present here to attend this event of official nature on behalf of Stekom University in event today. We will learn about very interesting and useful material by all of us from speaker as professor from Zaporizhzhia National University. I hope at this visiting lecture today, we have for all audience have a beneficial for all audience. I offer my regret to Dr. Joseph Teguh Santoso as our director at Stekom University and professor from Zaporizhzhia National University, Ukraine, and also all audience, the visiting lecture will be held in 6 series for 6 days. I wish this event enlightened us all and provide us with approach to deal with the problem of tomorrow. Thank you to everyone who made this money positive visiting lecture even possible, for especially specification, especially for the student of STECOM. Please enjoy this event, take some notes, ask questions, and we play together. Thank you. Well, I don't want to take too much of your time. I need to hand over it to Miss Novita, our today's MC, to introduce you our guest speaker to all of you. I would like to say once more on behalf of this seminar organizer, welcome. It is great to see so many of you here. Thank you. Thank you very much.
Yeah, thank you for Mr. Bibi. And next session, we have presentation on Professor from Zaporizhzhia National University, Mr. Serhi Choprov. Yeah, for Mr. Serhi, maybe you can start for this class today. Thank you.
Okay. Can you see my screen?
Yes, we can see your presentation, PPT.
Yes. Can you see my slide? Okay. Okay. So let's start. As for me, it is a very great pleasure for me to take attend in such event, and it very good opportunity for me, and I very glad that you invited me on your event. So, dear students and colleagues, I'm going to discuss the topic that I called neural networks in mechanics. At the beginning of our discussion, I would like a bit introduce myself. As you know, my name is Sergei Choprov, according to the Ukrainian pronunciation. I take a position of the head of computer science department in my university. My scientific degree is Doctor of Technical Science. My researches are devoted to mathematical modeling, computer-aided design, neural networks, evolutionary methods, etc. I wrote more than 100 scientific works, including monographs, articles, software licenses, etc. I'm going to discuss the application of neural networks in mechanics using the problem of state prediction of a rectangular plate with a circular cutout. So the plan of my presentation is following. After a brief introduction to describe the problem statement, the next step to review the design of the neural networks. After this step, to discuss genetic optimization of the neural network hyperparameters. Next, to review results of the numerical experiment, and finally, to make some conclusion. Artificial neural networks are one of the 6 disciplines of artificial intelligence. It allows us to teach computers how to perform problems, providing examples of how they should be done. A neural network is a useful tool for abundant data, also called examples or patterns, explaining a certain phenomenon. The world is quietly being reshaped by artificial intelligence since introduction in computer science. The artificial neural network is probably the oldest and the most powerful technique of artificial intelligence. Artificial neural networks also lead the number of practical applications, virtually covering any field of knowledge. Applications of artificial neural networks to engineering structures appear in a variety of industries such engineering, automotive, space structures, etc. Artificial neural networks allow to develop models, for example, for the strain state estimation of some type of solids. The computer-aided design requires the development of methods and software for fast estimation of stress components during the process of the design. The classic methods of mathematical modeling, like the finite element method, allow to evaluate the stress-strain state with a good accuracy. Nevertheless, the finite element analysis is a time-consuming process, especially for complicated domains. But the engineer should make decisions in time of designing process. Moreover, the preparation stage that includes machine routines, cloud, could also be time-consuming. A possible alternative is neural networks using. The artificial neural network could be trained over a data set of an object states and then employed as interactive assistant in the design process. Genetic algorithms are one of a class of approaches often called evolutionary computation methods used in adaptive aspects of computation search optimization, machine learning, parameter adjustment, etc. These approaches are distinguished by the fact that they act on a population of potential solutions, whereby the majority of search algorithms take a single candidate solution and make small changes to that, attempting to improve it. Evolutionary algorithms adapt an entire population of candidate solutions to the problem. These algorithms are based on biological populations and include selection operations which increase the number of better solutions in the population and decrease the number of poorer ones. And other operations which generate new solutions. The algorithms differ in the standard representation of the problems and in the form of relative importance of the operations which introduce new solutions. Genetic algorithms are so-called population-based search strategies. They maintain a set of points, so-called genomes, in a function space and try to make use of analogies to biological evolution by performing mutation and crossover operations between the individuals of a population. Starting with an individual population, the algorithm involves by iteratively creating a new generation of individual based on an already existing one. New individuals are introduced by a so-called crossover operation, where at least two individuals of a generation are chosen as parents. Their genomes are combined to produce children. On some of the newly generated children, a so-called mutation operation is performed by replacing a part of the child with a random value. Depending on the genetic algorithm, at hand some individuals of the pattern generation might survive into the following generations. Individuals are chosen for mating based on their fitness. The fitness is a metric indicate how good an individual represents solution of the problem. The rapid development of computer technology in the 20th century led to the fact that a significant part of computing work was entrusted to computers. Due to the high speed of calculations, their low cost and sufficient accuracy for many applied problems, it became possible to use methods heavy in terms of computations and time expeditious for solving mathematical problems. Examples include enumeration methods, iterative methods using large amounts of statistical data. However, along with the previously created solution methods and algorithms, new ones began to appear, the existence of which apart from the computer is difficult to imagine. The first work of using genetic algorithms in artificial neural networks appeared at the end of 90s of the 20th century, and already by 1994, according to few researchers. Most often, the neuroevolutionary approach is used in adaptive control problems, multi-agent systems, and systems of artificial life. The increasing popularity of artificial neural networks leads to an increasing number of researchers devoted to the development of artificial neural networks for modeling various fields. Modeling of solids, the stress strain state is also a possible domain of artificial neural networks applications. For example, some researchers explore the possibilities of machine learning to solve the problems of fracture mechanics. In scientific researches, we can find the Kalman filter-based neural network that employed to predict the collapse of highway on a bridge processing temperature and oscillation data, as well as the self-organizing map of Kohonen is devoted to detect fracture using vibration. Data could be found in researches of scientists. Or neural networks for the prediction the maximum displacements in rail beams, etc. The data set is generated using the finite element method. Parameters of a plate are randomly generated with the following restrictions that you can see and at the current slide. The restriction are chosen from the general observations that typical mechanical problem is devoted to majority of metals and alloys. So we choose the Young's modulus from this interval. We limit dimensions to reasonable sizes during our experiment and restrict the thickness of the plate to have to deal with thin plates. So because we are going to employ the finite element method as the generator of the simplest of the sample solutions. We design our neural networks in the considerations that we can have arbitrary boundary condition on any edge. We know that the plate has 4 edges, and boundary conditions are applied to these edges. In numerical experiments, boundary conditions are also randomly generated. New of the following boundary conditions could be applied to each edge of the plate. The edge could be free, supported, or clamped, or in other words, fixed. Hence, a boundary condition could be processed as categorical data. Any combination of boundary conditions is possible, excluding combinations of 4 free edges or 1 supported edge and 3 free edges, because such combinations, for such combination, we cannot find the solution. If we denote by C0 a boundary condition that applied to the edge, to the left edge, by C first boundary conditions that applied on the bottom edge, and by the C third boundary conditions that applied on the right edge, and by C fourth, here a little typo, by the boundary conditions that applied on the top edge. Then, if we enumerate a free edge, case of a free edge by 0, the case of supported edge by 1, and the case of clamped edge by 2, then our combination of randomly generated boundary conditions should satisfy the following inequality. For the rectangular plate, the boundary conditions include 76 possible valid combinations that could be represented by one hot encoding in the neural network. The model of the artificial neural network includes two input branches of neurons. Branches use dense input layers of neurons to separate an input of numerical data and categorical data. Each branch could include few hidden dense layers of neurons. Then the branches are merged, combining the output of the hidden layers for numerical and categorical data processing. So you can see the branch of numerical data, the branch of categorical data, the merge layer. After the merge layer, we could have an arbitrary number of hidden layers, and finally we have the top dense layer that produces displacements or stresses or both. It's our output variables. Of course, we have some uncertainty in this design because, as I said, we can have arbitrary number of layers at each branch, of hidden layers at each branch. We can have arbitrary number of layers, of hidden layers in after the merge layer. We can have arbitrary number of neurons in each layer, and we can choose any activation function. And in the process of design, we should make some decisions to optimize the design of such neural networks, and we employ the genetic algorithm to optimize the design. And the following hyperparameters could be encoded into an integer valued chromosome for the genetic algorithm. We could denote by V0 a number of neurons in the input layer in the branch of numerical data. By V first activation functions of the input layer in the branch of numerical data. The same for V second for the hidden layer, a number of hidden layers, and from V third from V fifth to V ninth, we have almost equal parameters similar, the parameters that are similar to the numerical data, but it's for categorical data. We selecting our genetic algorithm selects these parameters for categorical data, and finally we have very similar structure of parameters for merge layer and for hidden layers after the merge layer. Our model of artificial neural network includes 9 input parameters in the branch of numerical data, and as I said, 76 input, 76 input parameters in the branch of categorical data. We could suppose that in branches, each layer has at least the same number of neurons as the number of input signals. The model might don't include hidden layers at all, and we could limit the maximum number of hidden layers to 10. The maximum number of neurons could be limited by the maximum value, by the minimum value multiplied to 3, for example. The minimum number of neurons at hidden layer after the merge layer could be set to 1/4 of the total number of input signals. We could employ both hyperbolic tangent, sigmoid, and rectified linear unit activations at each layer, and we choose one from these 3 activations. We can enumerate activation functions by integers. For example, we can denote by 0 hyperbolic tangent, by 1 sigmoid, and by 2 rectified linear unit or ReLU. So finally, we can get the following restrictions for our variables, for our genomes in chromosome. This just concluding this section, these restrictions are chosen from some reasonable observations, for some reasonable limitations, to reduce the number of experiments and to reduce time that the genetic algorithm can spend during the process of neural network optimization. The scheme of the genetic algorithm is following. At the initial stage, we initialize our population. Then iteratively we apply, we calculate fitness, sort our population by fitments, increase number of past epochs, and apply crossover and mutation operations, to our population. I want to recall that in our task, population is the variety of possible configurations of the neural network. So for each chromosome of population, we train the neural network with using the parameter, using genomes of the chromosome. We calculate fitness using some estimation of error, and then optimize, and again we apply such steps again and again until we do not reach the stop criterion. So the loss function of the model is used as an output of a fitness function. The fitness function builds the model, trains it using the data set, and returns the value of the loss function for the trained model. At this slide, you can see the pseudocode of our fitness function. We build our neural network using the dense layers with specified number of units and activations. It's our parameters of it's our genomes, so it's part of our vector. So this, from this point to this, is our model. After this, after when model is built and compiled, we train our model using the data set, and for the trained model, we calculate the mean squared error on the validation data, and the mean squared error is our fitness function. So we select at each when we so at the process of optimization, the genetic algorithm selects the member of population with the lowest mean squared error, and using such selection, we always have on the top of our population the neural network with the lowest mean squared error. The crossover at the left part of the slide. The crossover combines genes of the population. The crossover selects the chromosome with the best fitness, so it means with the minimal mean squared error, and then the crossover combines it with other chromosomes. We use the multi-point crossover. It randomly selects M genes of chromosome and replaced it. I mean, replace selected genes by the genes of the best chromosome from the same positions. Here, choice generates a list of random integers without duplicates. Each integer is a value from interval from 0 to n-1. So it's possible positions of our chromosome. Number of generated random integers equal to swap value. We use a uniform mutation to avoid premature convergence. The mutation combines the worst M chromosomes with a new random chromosome similar to the crossover. At this function, by chromosome, I denoted the function that generates a new random chromosome. The data set includes randomly generated 40,000 records. we exclude records that don't satisfy the linear model requirements from the mechanical standpoint of view. If deflection, it means if deflection is not in the interval from 10 in power minus 5 to 1.2 or 1/5 part of words, then we cannot use the pattern in our data. For our numerical experiment, we use the population of 10 chromosomes and 15 genes. We for our experiment, we set m is equal to 7, and we configured the algorithm to stop if the best 3 chromosomes are not changed at least 50 populations. And you can see in this slide how the fitness function, how the fitness value was changing during the training process, during the population optimization. I want to recall that the fitness in our case is the mean squared error in the neural network. So you can see that the process of training stabilized, and we have, after something like its first 3 chromosomes, after 80 populations, we do not have any changes in our populations. On the next few slides, I show how changed some parameters of our neural networks. Like this is the number of neurons at the input layer of the branch of numerical data. And you can see as well that after 18, I don't show other numbers. It's stabilized and does not change in time. The similar plot we can see for the number of neurons at the input layer in the branch of categorical data. So we can see at the first, in the initial epochs, we have changes in our population, a lot of changes. At the top, it's the best chromosomes, I mean, of our population, but finally, after 80 chromosomes, we do not have any change. The number of neurons and the merge layer with very similar there's very similar picture with a very similar plot, and the number of neurons in hidden layers, moreover, it does not change since something like 13 or 15 epochs of the genetic algorithm. The genetic algorithm produced the following solution. The best chromosome specifies the following design of neural network. We have we have 21 neurons in input layer for numerical data, and we have 189 neurons in input layer of categorical data. The genetic algorithm estimated that we do not need any hidden layers in these branches, and we have we have 245 neurons in the merge layer, neurons in the merge layers. After this, we have two hidden dense layers with each layer includes 192 neurons, and finally we have the top layer that produces our output. In this case, in this training process, as an output, I used displacement in the plate, and we see how the mean squared error plot. We can see this plot, the mean squared error for the best configuration of the neural network. And conclusion: genetic algorithms are general purpose search algorithms which act on a population candidate solutions. They can be applied to search on discrete spaces, so can be used to search rule sets. Representations of computer programs or computer structures, neural network architectures, and so forth. When applied to learning, genetic algorithms turn learning tasks into reinforcement learning problems. It is in this domain where they are often used. Genetic algorithms combine quite successfully with local search algorithms or local machine learning methods. The genetic algorithm allows to reduce the mean squared error in the artificial neural network, verifying its architecture. The best chromosome of the initial population defines the model of the artificial neural network with the mean squared error that approximately equals to 4.7 times 10 in minus fifth power, while the same chromosome in the last population defines the model with the model of artificial neural network with the mean squared error that is worse. We can see that genes are changed slow, so some premature convergence is present. Hence, crossover or mutation procedures should be improved. The obtained artificial neural network allows to estimate the stress strain state of a rectangular plate with a circular cutout with reasonable restrictions. Such pre-trained artificial neural network might be used as an interactive assistant in computer-aided design or computer-aided design software. Of course, I understand that the accuracy of artificial neural network is less than the accuracy of the finite element method. But when the researcher in the design process, he should make decisions in the time of such process, and the neural networks could be employed to very fast, not very accurate, but to very fast highlighting of some problematic places in the construction that designed that is under design at the moment. I mean, our experiments, our investigations show that typically we can get error of artificial neural network comparing to the finite elements method, something like from 10 to 25% error. But we did the experiments the experiments using encoder-decoder generative neural networks to generate possible distribution of stress components. I mean, picture of the state in the construction by the construction geometry. So, from my point of view, this topic is very perspective and could be explored in many different applications, and many different problems could be planned for many problematical domains. And probably this all from my end, and I can answer your questions. So I finish it, and our moderator could invite students to ask questions.
Yeah, thank you for presentation. Maybe any audience wanna ask something, you can raise your hand on, or you can write in room chat. Yeah, just a moment, please. Oh, we have first question from Miss Abigail Azeda. Yeah, thank you.
Yes, thank you. Can you hear my voice clearly?
Yes, I can.
Okay. For Mr. Serahi, is the artificial neural network, or usually it can call ANN, can be applied in the future?
Do you mean could be applied to different to other constructions?
Yes, for ANN, all of the ANN, for all of the artificial neural network is that can be applied in the future for anything.
Not for anything. Not for anything. We always train the artificial neural network using data from some problematic domain.
Oh.
So the neural network is always trained to solve some problem.
Oh, okay.
We can train it to recognize a face like it does our cell phone, or we can train it to solve some task like I did in my research, or we can train it to generate a picture.
Oh,
but
okay.
It's always different neural networks with different designs and different hyperparameters that should be in each case it should be designed. The design should be optimized. Finally, the design, the neural network should be trained using data. So we need somehow to collect such data. In the case of mechanics, we can collect data using different approaches. For example, it could be experimental data, or it could be artificial data, like in my case, I applied numerical methods to generate data for training. Miss Abigail, I cannot hear you.
Little bit noisy, but thank you for your answer. It's really helped me to understand it. Thank you.
Thank you.
Okay, thank you. And the next question we have from Miss Santi Widyasturti. Yeah, for Miss Santi.
Hello.
Okay. Good afternoon, Mr. Serhi Koporov.
Miss Santi dulu ya.
Good afternoon. Okay, I'm an ordinary people, but honestly, I don't understand about your numeric algorithm. But I'm interested about the machine learning or artificial intelligence in food and beverage business. And I want to know, can you explain how we can, or the robot can choose, especially food or fruits, fresh vegetable, especially from the robotic, between better or not? I want you to explain how can the robot in artificial intelligence can choose the fresh of vegetable or fruit. Thank you.
No, I did not develop it for robotics, but I developed other neural networks for other tasks, and as well I developed neural networks for faces recognition, for images recognition. So if the robot has some depth sensor, and we have data to train artificial neural network on such data. For example, in my experience, I developed the neural network that then we designed it using this network. The robot, we used embedded device, NVIDIA Jetson Nano, that trained it with camera to recognize elephant, to recognize other Africa animals like tiger, lion, giraffe. I don't remember all people. And then finally we created robots that controlled where animals in jungles. And I developed neural networks that using the sound sensor of such robot, and those neural network recognize it whether we have a gunshot or not, so whether we have some people that tries to catch these animals or not. I answered your question.
Okay. I think you mean that the robot in machine learning or artificial intelligence have a sensoric in their machine, you mean, or something else?
Yes, but for the robot, we should use pre-trained neural network. So we train, for example, in my experience, when I developed the neural network for animal detection by robot, we trained it using data using cloud. Then pre-trained neural network was saved in the robot scheme, and the robot by pre-trained neural network and his sensors detained was detecting gunshots and animals in Africa, in Brasilia, and other countries where we tested those robots.
Okay,
But
sir.
my part was not the robot itself. My part was on the neural network.
I think it can be choose that they have a sensoric inside, and they can decide that between good or not in their food or food, isn't it?
Yes.
Okay, thanks
Definitely yes.
you. Okay, thanks for explain. See you.
Thank you for your question.
Yeah, thank you. And the last question, we have Mr. Widyarthi. Yeah, for Ms.
Okay, thank you. Thank you for Mr. Sergey. I want to ask question. I'm really curious about this. How your opinion about metaverse, from Mark Zuckerberg? I think that's a warm topic recently. Thank you.
Repeat, please.
Okay.
What my opinion about what?
About metaverse, Facebook.
Facebook, yes.
Yes. Now that's metaverse from Mark Zuckerberg. How your opinion about this?
Do
It's
you
a
mean
warm.
Meta company?
Yes. That's
Yeah.
what opinion about this?
About this company and about the social network.
Yes.
I think we know it does not the topic of my research, but as any human and as many people, I also use some social networks, and I see that social networks and IT companies grow, and each company becomes more powerful, and Facebook and the Meta company, like it calls recently, is a very big company that affects life of many people during the world. And in my point of view, the key question regarding such company is how data that the company provides to the consumers, to people, is moderated, is cleared, and whether this data is truth or not, whether this data is extremic or not, because when the internet removed any borders, but it also removed any filters of data, and we have a lot of influence of people to each other, countries to each other. So my opinion, the Facebook is good big company, but the work of such companies should somehow be controlled by probably government, by local governments. It's because it grows very very fast.
Okay. I understand. Thank you.
Okay, thank you for the question. I think we don't have no more question. Yeah, maybe can we have a session for closing? Oh, we have some question again. Just a moment, please. for okay, I think we have okay, I just a moment please. I think I will check for okay, I think we have sorry, we don't have no more question. May I closing for this event today? Yeah, thank you for this event. I guess no one else is asking. Okay, yeah, thank you for coming to this event. I hope we can see you again in the tomorrow visiting lecture. Thank you for Mr. Sergey Choprov. Yeah, thank you for coming in this today event. Thank you so much.
Thank you for the invitation, and it was a very good experience for
Yeah.
me to attend in this international event, and I happy that you and you asked questions, so my lecture was I hope interesting for listeners, and I hope to see you again tomorrow on your afternoon.
Yeah, thank you so much. And see you again in the tomorrow. Thank you. Thank
Oh,
you so much.
sorry.
Yeah.
Yeah, can you hear my voice right now?
What's yeah? How may I
Okay.
assist you?
Yeah, thank you. May I ask one question again for Mr.
How about
Serhi?
Mr. Sergey? Are you agree for this?
Yes, okay, no problem.
Yeah, thank you for giving me them again. And as you said before, neural network cannot apply for all things. But I ever read about it, but just little in some article. And if the neural network is also helpful in the medicine, but how it works, I mean for helping it in medicine. Do you have opinion about it, sir? For neural
Yes, I
network,
have opinion about application in medicine. In my point of view, medicine is very good place where artificial intelligence methods could grow and could very fast grow because we can see that neural networks and artificial intelligence solve daily tasks like face recognition, like finger point recognition, like for cars, like car automotive car controlling and so on, like Elon Musk does for his Tesla. Of course, we already have completed artificial intelligence methods for detection of very scary diseases like cancer or so on. And as for me, we should apply and we should optimize artificial neural networks and other machine learning methods to detect diseases, to produce new formulas of medications. Because in our scare time of the COVID, to get the simple medication, not only vaccine, but the simple medication against the virus is very, very actual problem. And in my opinion, I hope that artificial intelligence methods are employed by companies like Pfizer, like Johnson and Johnson to solve these problems now.
Yeah, thank you so much. And I hope also in maybe some company in here is that for helping for medicine. Thank you.
Thank you for your question.
Yeah, thank you for this event. Thank you for Miss Azeda for your question is so good. Yeah, see you again in tomorrow event. Thank you. And bye bye. Goodbye.
Bye bye.
See you again.
Thank you, Mr. Sergey.